Algebra 2 students, today's lesson could well be entitled Learn to Talk Like a Mathematician. See, your very first lesson today is going to be a vocabulary lesson. And one thing I want you to realize is that every language, every field of study you can partake in has its own language. It has a way of talking that's unique to other fields of study. And let's actually relate this to your lab for a second, your labs. Here's an example from auto tech. If you're in the auto tech lab, look at all these words here. You need to learn to know what these words mean. I know what a lot of these mean, but I don't know what they all mean. Okay, gasket, gauge, gears, generator, gloss. I know what most of those mean, but I don't know what all of them need. But if you're going to study auto tech, you need to know all these words. You need to learn all of these words. Let's do another one. Dental assisting. Same thing. I know what some of these words mean. Amalgam, anesthesia. I know what a bite is. I know what braces are. But there's some words on here I'm not sure of. Dentifrice. I don't know. Endodontics. I'm not really 100% sure. If you're in dental, these are words you need to learn and you'll be using on an everyday basis. Let's do one more. Catering. Culinary arts. Food. I have a general idea of food. I'm sure there's some words on here I don't know. I don't know what au jus is. I've heard of it. Blanche. I don't know. I've heard that word. I don't know exactly what it means. Bisque. Okay, I know what that means. Cordon bleu. But at any rate, if you're in culinary arts, you need to learn these words. You're going to use them every day. Well, fast forward to algebra class. In algebra, there's certain words I'm going to use on a daily basis. You need to know what they mean. So I want this to be an interactive lesson. You need to grab a piece of paper. Pause the tape right now if you need to. Go grab a scrap sheet of paper. But what I want you to do first is write down this 5x plus 18. Write this down on your paper right off the bat. And then let's start asking some questions about this. So if I have a problem 5x plus 18 in algebra class, is this an equation? And the answer is no. 5x plus 18 is not an equation because the word equation implies that problem has an equal sign. And 5x plus 18 does not have an equal sign. So what can we call this? If a problem like this is not called an equation, what do we call it? Well, maybe some of you can guess it right now. It's actually called an expression. A problem in algebra class with no equation, that's called an expression. Okay, so these words here, equation and expression, I want you to write these words down. I'm not giving you a fancy definition. I'm giving you a really simple definition I'd like you to write down as well. All right, let's break. And if you're curious, equations can be solved. Okay, equations are meant to be solved, but expressions cannot be solved. An expression like 5x plus 18, you can simplify it. You could try to factor it. You could try to evaluate it, but you can't solve it. Okay, so we'll get into that as we go along in this unit. So let's break down each of these individual numbers now. Here we have 5x, 18, 5, and x. What do you call each of these kind of individual when we break this expression down? So the 5x, I want you to write 5x on your paper, and below it or beside it write, this is called the linear term of the problem. 5x is called the linear term. Whatever term has the variable, in this case I'm just going to say has an x, we call that term the linear term. And then we also have another term in this problem in 18. The 18 then is called the constant term. And the constant term has no x. Again, I'm trying to keep these definitions as simple as I can here. So that's the linear term and the constant term. Now we can break the linear term down even further as well. The linear term has a 5 and an x. Let's start with the x. I already hinted at what the x is called. The x in this problem is called the variable. So you think about what the word, I think everybody knows what a variable is, but trying to define it, put into words, is a little bit trickier. So here's the definition I've come up with. A variable is actually, it represents an unknown number. In any problem when you don't know what a number is, you can use a variable to represent that. It's an unknown number represented by a letter. That's the simple definition we're going to use today for variable. You could also reword that and say it's a letter representing an unknown number. And then the 5. The 5 is the number in front of x, the number in front of your variable. And it's another C word. It is called the coefficient of the expression. And then specifically, it's called the coefficient of x. So since 5 is in front of the x, it's called the coefficient of x. And it actually means that the 5 is being multiplied by the x. Okay, the last question I want to ask you then, how many terms does this expression have? How many terms does 5x plus 18 have? And the answer is it has 2 terms. Okay, it has the 5x and it has the 18. The definition you can write down for a term is the number of terms is determined by how many things are being separated by a plus sign or a minus sign in a problem. So that's why this has 2 terms. There's one plus sign, it's separating the 2 terms. What's kind of funny about this is you can actually have like a really large expression. Like I could have 109 x to the 3rd y to the 7th over z, this seemingly really large expression, and that would count as simply one term, which is called a monomial. 2 terms, by the way, is called binomial. We'll focus on that later. And then you could have a seemingly have a seemingly smaller expression like this, and this would be considered 3 terms because there's 2 plus signs here. And you know what? I'm going to make one of those plus signs a minus sign just to show it could also be a plus sign or a minus sign. That's how you determine the number of terms in a problem. Now in tomorrow's lesson, we're really going to dig into starting to solve equations. Before we do that, though, I want you to write down on your paper these 3 keys to algebra. Here they are for you, all 3 of them. It's my opinion that if you can really understand these 3 concepts, forwards and backwards, and have a great grasp of these 3 concepts, then you will be wildly successful in algebra class. This is kind of the foundation, in my opinion, of what we learn to really study in algebra class. So let's dive into each one individually. The first key to algebra. All algebra is fill in the blank. So I wrote a fill in the blank problem on the screen. 5 times blank plus 6 equals 56. Consider the answer to this question for a second. I think most of you could figure this out just using your brain power, right? You could even do trial and error. You could try like 5 times 8 plus 6, 5 times 9 plus 6, 5 times 10 plus 6. Ding, ding, ding. The answer is 10, because if you do 5 times 10, you get 50, plus 6 gives you 56, right? So the answer is 10. Well, in algebra, what we do is we take fill-in-the-blank problems and we write them a little bit differently. Instead of writing 5 times blank plus 6 equals 56, we use variables. In algebra, we would write this problem as 5x plus 6 equals 56, and the instructions would say solve. Now, the answer would still be x equals 10. But I just want you to realize this concept. When you need to solve an equation, all you're doing is filling in the blank. All right, let's go to number 2. Number 2 says algebra involves working backwards. And we spend a lot of time working backwards in algebra class. And in order to work backwards, you have to understand opposites. Now, some opposites are really obvious. For example, the opposite of addition, super obvious, it's subtraction. The opposite of multiplication, also, I think very obvious. The opposite of multiplication is division. But as we go along further in this class in Algebra 2, we're going to get into some trickier opposites. For example, do you know what is the opposite of a square, like x squared? Hopefully some of you know the opposite of squared, the opposite of x squared is a square root. The square root of x squared and the square root of x are considered opposites. And then you can get into some really tricky ones as well. What about an x power? What about a power of x? What's the opposite of taking 10 to the x power? Well, I think this one's the trickiest one of all. I don't know if you've learned this or not. It's actually called the log of x. All right. So in order to do well at algebra, we need to understand opposites. Now, the last key to algebra, in my opinion, I call it the golden rule of algebra. Maybe you've heard the golden rule of relationships before. That says, do unto others as you would want them to do unto you. Well, the golden rule of algebra is kind of a play on those words. Do unto the left of the equal sign of an equation as you do unto the right. Well, let's kind of put all three of these keys together into one problem. I wrote here, we're going to solve this equation. 5x plus 6 equals 56. So first thing I want you to realize with this problem, you could answer this equation without any algebra skills, as long as you understand it's just a fill-in-the-blank problem. Okay? Some of you already know the answer. Well, the answer is 10 because you can fill in the blank. You know that 5 times 10 plus 6 gives you 56. And that's good. That's great to be able to guess and check your answer. That being said, we're not going to spend this entire course learning how to guess and check. Okay? We want some skills, some tools that we can use. Let's talk about working backwards.
Time for another announcement.
Being able to work backwards gives you tools to be able to solve and manipulate equations. For example, I see my problem here. I have this linear term 5x and this constant term plus 6. You know, I can make that plus 6 vanish by using opposites. The opposite of plus 6 is a minus 6. And if I put a minus 6 directly below the plus 6, guess what? That constant term vanishes, and I'm simply left with the 5x. Yes, you're allowed to do that in algebra if you understand opposites. Now, the last part of this is the golden rule of algebra. You are allowed to take a 6 away from the left of the equal sign as long as you also do it to the right. So on the right-hand side, I'm going to do 56 minus 6, which leaves me with 50. Okay? And then here I have this linear term 5x. The 5 is being multiplied by the x, so if I want the 5 to vanish, I can actually divide it away. I'm allowed to put a divided by 5 underneath the 5x, and the 5 vanishes. Now with the golden rule of algebra, if I do it to the left, I also have to do it to the right. Now 50 divided by 5 is 10. So you see, using these tools of working backwards and using the golden rule of algebra, I had this little process in place where I was able to get the same answer, x is equal to 10. That's also the same answer you'd get if you were able to guess and check. But both of these go hand in hand. So in the next lesson, we'll really dive in on being able to solve increasingly complex equations. But for now, practice these words, get used to using these words, make these a part of your everyday language. Farewell.